Okay, solving limits numerically sometimes becomes necessary if you can't do it algebraically or graphically. I'm going to show you a few functions. They're weird functions, but they show up in modeling situations where we need to use numeric limits. Okay. So we've studied graphical and algebraic. You've seen numeric limits before. I think you're going to understand a little better because we did it with continuity. We just didn't call it a limit. So the base concept of numeric limits if I want to approach some x value, basically what we're trying to do is get as close as possible from the right side. So let's say the x value is 4. I'm going to start from the right. What's number above 4? Let's say 4.1, right? That's kind of close to 4. And then I'm going to go to like 4.01. That's closer, right? And then I'm going to go to 4.001. And I'm going to get closer, right? So it shows me, numeric limits show me what's happening as I get closer to that point. Okay, from the left side, I'm going to do like 3.9, 3.99. So we're squeezing in on 4, correct? We're coming in from both sides because the limit requires both sides to be the same number. We're going to the same spot. Hopefully, both of these sides get us to the same number, our limit. So let's talk about this function. Okay, what do you get if you plug and chug? Yeah, an indeterminate form, right? Can you simplify it algebraically? No, you can't, because you can't cross x's out. Remember that algebra atrocity? Okay, do not do that, please. I will smite you. Graphically, does anybody know what that looks like? Yeah, throw it in your calculator. I do a zoom standard, or a zoom Traig, I guess what you should do. Put it in radians mode. Some of them might be in degree mode. So make sure you're in radians mode and do a zoom Traig on the zoom screen just to get the window in a friendly format. Are you in radians? Yeah, it is. You typed it in there?
Oh, no, I didn't.
No, you didn't. Okay. What do we got, Jose? Yeah, so I see some errors. Some of you are typing this in. What the heck? Oh, not again.
Oh, no.
Oh, bummer.
We'll have to use the whiteboard.
Some of you are typing that in, right?
I closed the print.
And you get just a line. Okay, so make sure you're closing the parentheses. It should, if memory serves me correct, What does yours look like?
Straight line.
I think that's a white. Things like this. I somebody.
Did you get a different graph this time? This is my calc book. What does it look like? Is it just a little? Something like this? We know it doesn't. Yeah, that's a little exaggeration there on the back end, but so obviously there's a hole because it's undefined at 0. Okay. You can look at the graphical solution. What's the answer? What's the y value where that happens? 1, yeah. Okay, so graphically is an option here. But numerically, we need to get closer and closer from each side and see where those numbers converge. Okay. So if we do a couple of tables, I'm going to change this up a little bit, see if it works for you guys. So coming from the left side, we're going to have numbers that get closer and closer to 0, right? And from the right side, numbers that get closer and closer to 0. So we're coming from the right. So I've actually drawn my table so we're coming from the right and from the left. Okay. The question is, are these going to the same number? That's the question. Okay. We think it's 1 because of the graph, right? So go ahead and plug negative 0.1 in to your calculator. Sine negative 0.1 over 0.1. Negative. Okay, do the other ones. Do negative 0.01. The thing about these is you have to go to a lot of decimal places most of the time. Do you guys know the second entry trick? Okay. I think I taught it to you. You remember? What'd you get? Oh, that shouldn't be a negative, should it? How many? Go till it gives you an 8. How many decimal places till it gives you an 8?
4, 9.
Okay, and now do 0.001. And you're going to see that it's
0.9.
okay. So is that getting closer to 1? Okay, what do you think is going to happen when we do this side? It's going to do the same thing. Okay, we're going to have actually the same values. So we can see from each side we're coming closer to 1. So we can actually say that our limit is 0 or is 1. Okay, so we can actually declare that our answer. Remember, the limits are going towards something, not necessarily being at it. You okay with that? Does that make more sense now than it did with continuity? Yes or no? You can be honest. That doesn't. Oh, it did. Okay. So not more sense, but it's still okay. Do you want me to show you another one? You think you can handle it? Okay. Let's look at a log. The limit as x approaches 1. Natural log x over x minus 1. Yeah. There is another cosine example in your book if you want to look at it. So we're going to be going towards 1. Okay, 1 is our ultimate goal on the x value, right? So if we're going to the left of it, and to the right of it. Oops, don't need a 0. So as we come from the right and from the left, what's our limit? So we're looking for that number right there, the y value. Does anybody not remember the second entry? Make it fast on a calculator. Okay, so type in this one in for x. ln x over, remember to put the bottom in parentheses. Get there, Jose.
And then
E to the what? So point. You should be getting close to 1. So Jose's right, actually.
Why did I do it wrong?
I got negative 0.999.
Wait, that's the wrong, sir.
So you put 0.001. That's a 1.
1.0.
Yeah.
You did 2 million?
And then Jose hit second, enter. How it brings it back up again. All you have to do is delete a 0. And then your next one, you can just replace that with 0.999. Just 3 decimal places. And you get that answer. And then you can replace it with 0.99 and then 1.1. You're just kind of bouncing back and forth on that. 4, 5 spots, 4 spots, 3 spots. So what are we getting for these?
for the 1.01, I got 0.00985.
And then 1.1, I think, is
0.08.
something's wrong there. Yeah, this is what the book has. Okay. On the left side, you should have, oops, one more. Those numbers. So we can see that we're going towards a y value of 1, correct? And that's your limit. It's just a numeric analysis. If you want to, feel free to use your tables in your calculator to generate these values.
Yeah.
Do you know how to do that? Okay. If you put this function in your y equals screen, you're typing something wrong. Don't know what it is.
Then it feels second table.
Yeah, go to table setup first. And put your start value at 1, because that's your x that you want to find, right? So you want to start with your x value, and then change in table, or change in x, right? Is what it says. Oh, okay. If you put 0.001, you're going to figure out these two numbers first, because there's 0.001 from 1. The next step would be to change this value to 0.01, and then you can go get these two. Okay, so you just have to play with your table setup. Anybody want help with that? We're good to go. And then go to your table and it should show you values. It's another way to do it. Okay, I will, let me write the work down for you guys and then I'll help individually. Okay, this is a mixture of all three methods, graphical, algebraic, and numeric. So you're going to have to kind of figure out which one to use. Remember, the spiraling is due with it on Tuesday. Well, that's due Tuesday.